Hello everyone, welcome to this video lesson. In this video lesson, we would like to talk about bracket series in hydrogen spectrum. We know as per the Bohr's atomic model, 1 by lambda, which is called as a wave number, is equal to Rydberg constant of 1 by n1 square minus 1 by n2 square, where n1 and n2 are the principal quantum numbers. When electron jumps from the higher orbit n2 to the lower orbit n1, there is an emission of energy. That energy is emitted like a photon. That photon is going to have a particular wavelength. That wavelength we are going to find out in this case. If n1 equal to 4 and n2 equal to any number other than more than 4, 5, 6 onwards till infinite, then the corresponding spectral lines emitted are called Bohr series in hydrogen spectrum. The spectral lines are called, not Bohr, bracket series of the hydrogen spectrum. We would like to know what are the maximum and minimum wavelengths in this case. When electron is jumping from the immediate orbit, that is, as n1 equal to 4, n2 equal to 5, the energy emitted will be minimum here. Energy emitted will be minimum. As energy equal to h nu, that equal to hc by lambda, inversely proportional to wavelength. As energy is minimum, the wavelength will be maximum. Would like to derive an equation for that. So 1 by lambda maximum is Rydberg constant of 1 by n1 square minus 1 by n2 square. That is Rydberg constant of 1 by 24 minus 1 by 25. So if you calculate this value, that is Rydberg constant of 24 and 25, is going to be 400. 25 minus 24 is 1. So 1 by lambda maximum is r by 400. Therefore, automatically lambda maximum is 1 by 4 square is not 25. Yeah, we need to make a small correction. 4 square is 16. So 16 and 25 is 400. 25 minus 16 is 9. That implies, simplifying this further will give lambda maximum is equal to 400 divided by 9 into Rydberg constant. That is one possibility. The next possibility is if n1 equal to 4 and n2 is infinity. So electron is jumping from the highest orbit, therefore energy is maximum. As energy is maximum, corresponding wavelength is minimum. We can write that equation. 1 by lambda minimum equal to Rydberg constant of 1 by 4 square minus 1 by infinite square. So 1 by lambda minimum is Rydberg constant by 16. So lambda minimum is 16 by r. If you calculate both these values, they happen to be in infrared region. So bracket series is not visible. Both maximum and minimums fall into the infrared region. We can also calculate the values of ratio of lambda maximum to lambda minimum in the bracket series. We know lambda maximum is 400 by 9r, lambda minimum is 16 by r. So the ratio will be 400 into 16 by 9, whose value is equal to be going to be having a value of 25:1. that is lambda maximum to lambda minimum of the bracket series. Yeah, 3, we can simplify it like this. We can also draw a diagram. This I want you to once cross check. If you draw the spectral lines of this, we can start with say n equal to 1, 2, 3, n equal to 4, equal to 5, 6, 7, and so on infinite. If you draw the spectral lines, if electron jumps from the immediate orbit, lambda will be maximum, energy will be minimum. If electron jumps from the highest orbit, energy will be maximum, lambda will be minimum. And you can find the spectral lines in between, and all of them are in infrared region. That's how we can explain the bracket series of a hydrogen spectrum. Thank you for watching. Keep coming back for more and more video lessons. Thank you.